In class, we describe freefall motion or define freefall motion as being the motion of an object subject only to the influence of gravity. So this is totally ignoring air resistance, and it's when the object has to be dropped, thrown up, or thrown down. In our lab, we demonstrated freefall motion by tossing a SmartCore golf ball and a plastic hollow ball, meaning the objects were both in freefall, but our lab had many differences to the freefall motion that we learned in class because that was kind of in an ideal world. So that our lab demonstrated physics with air resistance too because we're not in a vacuum, so the objects were subject to air resistance, so there are going to be a few differences in the numbers. We learned in class that the acceleration will always be negative 9.81 or positive or negative 9.81 meters per second squared. And when we drew the graph of freefall motion in class with a ball being thrown upwards like this, we drew it as being parabolic. I'll show that. So then when my group input the data from our video with the SmartCore golf ball into LogarPro, we also got a parabolic graph that closely related to the graph we drew in class, but with a bunch of differences in the numbers, or a few differences in the numbers. So the parabola is also concave up, and the velocity at the vertex, which is right here, is 0.009 meters per second, which is very close to zero, which is what we thought the velocity would be at the vertex of this parabola. My group also found the acceleration of the object to be around negative 8.14 meters per second squared, which is very close to 9.18 meters per second squared. But this is obviously different because the objects were subject to air resistance.